Hey everybody, welcome back to Organic Chemistry. My name is Todd Rothman, and in this video we're going to go over Section 3, the general mechanism. Now everything leading up to this point is really about learning this general mechanism. So it's kind of like the first two sections. They're very important for your exam, but they're also important just to get us to here, where we're at now. And this particular video is going to help us to organize the rest of this chapter. It's even going to give us an introduction to the next chapter, which isn't so much of a concern right now for you, but it's still nice to know that this particular introduction actually helps you with the next chapter as well. Okay, so let's get started. Now, as you can see, there are two different conditions, acid and base. Just like with all the other class 1, class 2 reaction. There's acid pathway, there's base pathway, right? So that's what we're seeing here. Now there's no neutral. That's the one thing. Unlike chapter 16 and 17, there is no neutral pathway. That doesn't exist. It's either acid or a base catalyzed pathway. So let me go and start off with the base. Now this is by far the most popular, right? So this is the most reactive pathway, and it's just the same like when I showed you about tautomerization, how I said to you that base is the most reactive, right? Now what we're going to do is I want you to realize something. This is something that you have to kind of get your head around, and it's really important that people get this point, that there's some sort of equilibrium that exists. Okay, so just bear with me a moment, and you probably don't want to write anything that I'm about to write down. Don't write it, okay? Just sit back and watch for a moment. Okay, we know that if, let's say, we have a ketone or an aldehyde or any of the classes that we talked about, and let's say there's some sort of nucleophile. Well, we know from chapter 16, if we're dealing with aldehyde and ketone, chapter 16, that we can get a nucleophile to come in, let's say twice, if this is an oxygen, right? So if that was like, let's say, water and oxygen, I'll be more specific. So let's say hydroxide in water, then we know that we can get this right here to happen, right? Where you get OH twice on the same carbon, right? That's chapter 16. Now we also know this is reversible. So there's a equilibrium between the two forms. Now remember that this is a hydrate, right? And remember how we said that whenever you have an aldehyde, it's more likely to do this, but a ketone is not, right? Ketones rather go back because it's more stable as a ketone than it is as a hydrate. So aldehydes, which are not very stable, tend to make hydrates more. Now, no surprise, aldehydes don't react as well as ketones do in this reaction here. Okay, but nonetheless, let's continue with the story. So this right here goes and becomes that and comes back around. And every so often, what's going to happen is that we're going to be able to use a base and deprotonate the alpha carbon. So that's just another thing that can happen besides having this go directly in. Okay, so every once in a while, we pull off an H, and all of a sudden, we have an alpha anion. Now again, this right here is in equilibrium as well. So it's constantly going back and forth. So there are three different states to this ketone. There's the hydrate state, there's the ketone state, and then there's this alpha anion, which will become an enolate state, right? So this goes and makes resonance, and this goes up. So there's the enolate. And so there's the keto, the hydrate, and the enolate. And there's a constant flow back and forth between these three states. Now, which one is the majority? The ketone, right? We know that hydrates tend to favor ketone side. And we know that enolate or enol tends to favor ketone side. But what's going to happen is that every so often we are going to wind up protonating the enol so that we can wrap this reaction up, just like we did with the hydrate, right? So eventually we get to hydrate, eventually we get to enol. And again, when that happens, so this goes here and pulls the H. Now, when that happens, we know that this is completely reversible, right? So you can lose this proton again, go back up here, shift this down, push this forward, get to here, and then protonate to get back to ketone, right? All right. So this is something that I want you to know is constantly happening. So what we see here is that there's a constant equilibrium. There's an equilibrium between the hydrate, the keto, and the enol. Okay, so there's a equilibrium that's constantly going on between these three. Now this is important, but we know that the keto tends to be the major form. This is the major form under water conditions. If we have hydroxide and water, this is the major form. Okay, now what happened is, or what we do, is we take advantage of the fact. Now we're going to ignore the hydrate. We're not going to think about the hydrate for this chapter. We know it exists, and we have to know that we can get that, but not right now. For this chapter, we're going to focus on what happens when you lose the alpha H, and it becomes an alpha anion, and then it becomes an enolate, and then an enol. Okay? Now, what we know is that this is going to wind up going back. Here's the general mechanism. When this right here, when this process, I'm going to go to a new page. I want to show you one more time. So, without looking at the enolate, the hydrate. So, when you have a base and it pulls off an alpha H, you become an alpha anion, right? And then this can go through resonance, which is not really important for us, but we will draw it out because it tends to be more stable, right? The negative on O is better than negative on carbon. So this is the better resonance form, right? So we get to this right here, and then from here, if we want to go forward, we would have water protonated, and we're at an enol, okay? So this is what we care about, the keto, enolate, and the enol. Whoops. Enolate is right there, and enol. Okay? So this is what we care about for the base pathway. Now what I want you to note is that what happens when the enol goes back around to become a keto? Well, the first thing it's going to do, if we kept going, right? So if we took this here, this enol. Let me delete that. Alright, there's the enol. I'll put them up there. Okay, if we took this right here and we started to reverse back out. Now I could just change the arrows to the left, but I'm not going to do that. I want to show you for a reason. You're going to see the magic of this pathway in a moment. Okay, so if I was to take this and have it lose a proton again, so let's say we have a hydroxide and it pulls off a proton, so now we're back to an enolate, right? So we're back here. And now from the, let me actually line this up. So we're going back around, right? Imagine this is going through the life cycle of becoming a keto to an enol and back to a keto, right? From a keto, enol to keto. Now, so here we got that, hydroxide. So now what's going to happen is we're going to do our resonance, right? And notice what I'm doing. I'm following my path right above, right? It looks the exact same. Now, normally, right here, we have water, and it's going to protonate it, right? So we went through a full cycle. Now, again, I hope you're not writing any of this down because this is just for your visualization. I want you to really connect with this concept. So we started as a ketone, we become an alpha anion, then an enolate, then an enol. Then we go back to an enolate, alpha anion, and then water comes and becomes ketone. Well, this cycle is constantly happening over and over and over again, right? So what we're doing is we're adding H2O, which is really H plus, onto this carbon. So what chemists realized is that if we just simply flood the environment with something positive more than H's, so like let's say we load up with a bunch of positive, then this alpha carbon will grab it. So we can kind of change the fate of this cycle, this life cycle here, this equilibrium that's happening by adding E plus. And what we do is we start flooding it. So we know this is happening because we make a basic environment. So we know this cycle's happening over and over and over again, right? And then we're going to drop into this environment a crap load of E plus, whatever this is, we're going to talk about soon. But we're going to drop in E plus, and what's going to happen is that this carbon here is going to wind up grabbing the E plus, and that gives us something completely different. You see, that's the product that we're making. Here's the new product. Okay, so we're getting an E plus added onto it. So this is the philosophy. Now you might say, well, sometimes actually we can get E plus to come here, right? E plus can go there as well, and we can get something like this. This happens sometimes, so this is also an option. But this option is not one that we focus on while we start to learn the chapter, because most of the time it's going to go back to become a carbonyl. because this really is trying to become a carbonyl. It's going back to the more stable ketone.